Hi everyone, welcome to my channel. In this video, I want to show you how I make a modification on my Ender 3 factory hot end. This is a factory hot end. As you can see, this is the only I modified is uh, the the heat block. And in below on description you can find all the component I used. Okay, let's start. The idea of hot end is, as we all know, is to melt a filament with an heating method and to generate heat with a minimum heat loss. How we can fulfill this idea into reality is a challenge that need to achieve. Uh, the hot end is composed in two sections. I call it in a feed section or the cooling, yeah, the feed section, and a melting or a furnace section. Actually, the hot end itself is resembles the plastic injection, uh, and this is break. This heat break is function both as a thermal bridge, so bridging the thermal, and a component connection, a structural between a feed section, or you may call it a cooling section, and a melting section. So this act as a bridge to connect uh, between this section. There are three main components on the hot end that has a significant impact on a melting filament at given temperature and for high temperature use. First, the nozzle. Secondly, the heat break. This is the nozzle, of course, and the heat break. And the third is component is heat block. Heat block. For better thermal conductivity, choose a copper alloy, or at least uh, a copper or a brass for both the nozzle and the heat block. So uh, it's better to use the same material uh, for better thermal conductivity. Uh, but on the opposite side, we may choose a titanium alloy or at least a stainless steel that have a poor thermal conductivity for the heat break. So we choose this material as low as possible for thermal conductivity. So it's the opposite side. The heat block and the nozzle need to be a very or higher thermal conductivity. First, the nozzle. Let's say this nozzle component is the most crucial part for successfully melting a filament within a specific temperature range and timing. So the heat from the heat cartridge from the heat cartridge traveling along the heat break and ended, of course, at a nozzle. The nozzle and the heat break ideally completely touching touching at this surface area. Yeah? So connecting between uh, the nozzle and the heat block is touching at this surface, ideally without any visual gap. In this case, if you can see, perhaps you can, um, there is a micro scale gap. So the best method for, as we all know, the best method for heat transfer is by heat conduction. So the heat generated from this heater will conduct to the heat to the nozzle, and any gap, any gap, how small it is, even at the micro scale within a nozzle and the heat block, will eventually reduce the ability for the heat to travel along. So that's why we need to tighten this screw to the heater, so the heater itself must contact completely firm, contact firm into the heat block. This screw is tightening. This also true for uh, apa, the nozzle. We need to tighten the screw as tight as possible, so to minimize the gap between uh, this area. Yeah? So the main purpose of the heat break, I'll talk another. The main purpose of the heat break is to insulate the heat travel from the heat block to a feed section or the cooling section. Any contact area, this is the contact area, is where the heat break is screw, need to be keep as minimum as possible. So it will be need to reduce a thermal runway. This is also true for a heat block, but with a different concept or idea. Whereas in the heat block is to keep the the build volume as minimum as possible. So this to reduce a thermal loss. So the thermal is keep minimum uh, loss. If you can see, I crop this size, this side. See, so I crop. This is to reduce the build volume of this heat block. Yeah. So and there is a small component. This is a custom made I make to enhance with the heat break, with this heat break, for a solid structural uh, that connect the connection between the uh, heat block and the feed section. Uh, it needs also to be made by titanium, if we can, if I can, but this material is only available, so I made from a brass. But I also kept the contact area, this is contact area, as small as possible. Actually, at the factory Ender 3 Hotend, there are two connection. So, but I only use one in order to keep the contact area minimum. But we need also to make sure that this part must be in good structural mechanical connection, so it is firm, it is not easy to bend, or you may say it's screw it. So when it operating, it is has no problem, even it seems to be small. So at high temperature, uh, this uh, uh, small connection, this small modification, like the contact area and cropping by this reducing the volume is noticeable at a very high sorry, at high temperature. Okay, so that's it. What I did to modify the hot end. Please make a comment and subscribe to my channel. Thank you for watching.